All right, we're right back where we started, and that's going to be looking at this illustration. Now, what we already discussed is the fact that in part of trying to test reachability from host 1 to host 4 in this particular illustration, I typed ping 192.168.0.4, which is the IP address of host 4 with a MAC address of MAC address 2 and an IP address of 192.168.0.4. Now, we already know that we can build the layer 3 header. So the layer 3 header can be put together, check. Why? Because I have the source IP and I have the destination IP and I have the source IP of this host. Everything that I need to know. Then what I do is I pass that down to layer 2, and layer 2 is going to need to be able to create the packet, but the problem here is I do not have the sufficient information. I know the source MAC address, and that source MAC address, we already said, is MAC 1. However, I do not know the destination MAC address. And we said that as part of this process, I can't send that information until such time that I learn that MAC address. So how do I learn it? Well, first of all, what I do is I take this piece of information and I place it in memory. A lot of books and texts call this a parking place. Can't stay there indefinitely, but it should be able to stay there long enough for this ARP process that we just described in the previous video to do its thing. So what I'm going to do is I'm going to send out an Arp request, and that Arp request again is going to say who is 192.168.0.4. And we already know that it's going to be sent to the all Fs MAC address. So, I mean, we've learned a lot up to this point. However, what I want to do is I want to talk about the behavior and how, let me move my stool out of the way here, the behavior and how our devices are going to respond to this. So, just for clarity's sake, to keep from having to erase this, what I'm going to do is I'm going to come over here and I'm going to redraw my switch. And again, we said that this switch had 4 ports on it. We said this was port 1, port 2, port 3, and port 4. Now, this is my switch. And we said that this switch had integrated into it a database. Now, we'll give that database a name here shortly. It's got a couple of names. But right now, just understand that it's there. So it's a database of information. Now, this database is going to be where I record information, and I'm going to record information about MAC addresses. But it's only going to be specific MAC addresses that I'm going to record. In fact, I'm only going to place entries in this database for source MAC addresses. This is part of what we refer to as transparent bridging or transparent switching. And we'll get into that in the next lesson. But just understand that in Ethernet we do transparent bridging. Now what that means is the host has no idea of what's happening. It's all handled by the switch. Remember, I said we surrender the entire process to the intelligence integrated into our switch, and that intelligence is baked into this database that we've been describing. So that's where the intelligence resides. Now, let's look at this idea of the all Fs MAC address, trying to prevent from having to write it down. So we know that right now this host is sending a frame into this switch. And we know that this switch, this frame, is referred to as my Arp Request. And this is how the switch is trying to dynamically learn the MAC address of a particular host. So down here's my host. So it's just this host down here. I'm just going to illustrate it here. And it has the MAC address of, we did MAC address 2. And it has an IP address of 192.168. And we said it was going to be .0.4/24. Now, when the switch receives this all F's MAC address, or a frame with a destination of all F's, what ends up happening is it performs a special function, and that function is going to be to flood the frame. Now that's the first of 3 primary behaviors that we're going to deal with when it comes to switches. The first one is going to be flooding, so I'm going to flood frames. The second is going to be I will filter frames, and the third will be that I will forward frames. All based on what I know that's being driven by this database and based on what we refer to as well-known MAC addresses, of which all F's is the broadcast or the flood MAC address. So what this implies is that as this frame enters this switch is actually going to replicate this frame. So what I'm going to do is I'm actually going to take this frame and I'm going to replicate it 3 times. And what I'm going to do is I'm going to send that frame out every interface on this switch. And just for clarity's sake, I'm going to send it out every switch that is, every port that is in the same VLAN. And we'll get into VLANs later on in our conversations. But understand that I'm going to flood this ARP request, which remember is who is 192.168.0.4 ? Now what's going to happen here is, when we take a look at this, the MAC address of the sender is actually going to be placed inside of this database. And I'll just go ahead and say it now. We call this the content addressable memory table. We call it the CAM for short. You'll also see it in a lot of old school books called the MAC address table. And we're going to take a look at it. But what it's going to do is it's going to say, well, in, let's just say VLAN 1, just so I can be precise, I don't want to surprise anybody later on down the pike, it's going to say MAC address 1 is reachable via port 1. And that's the only thing that this device learns, until such time it receives a packet that is being sourced from something else that it doesn't know. So in this scenario, what's going to end up happening is this ARP request is going to get sent out every interface. So the idea is that since it gets sent out every interface, it will ultimately arrive at the device that does have that address. And what's going to happen here is he is going to formulate his ARP reply. Now what I want to do is in the next video, I want to follow this ARP reply, and I want to build out the rest of this information. But it's also going to be important for us while I'm sitting here. We just talked about flooding. Well, what I want to do now is I want to look at filtering, because it's very, very easy to talk about filtering. So when do switches filter? Well, the switch operates under the assumption that this is a host. Therefore, if I'm trying to reach a destination from that host perspective, it makes no sense for me to replicate that frame and send it back out the interface that it arrived on. So that's why we only make 3. In this instance, I have 1, 2, 3 ports that I can send information out of. And what I end up doing is that instead of sending the third frame out of port 1 back the way it came, what I do is I go ahead and I perform filtering. Now, when I come back, what I want to do is I want to talk about the response to this mechanism as far as we want to look at the ARP reply a little bit more closely. So we'll do that when we come back, and hopefully we'll be able to round out the rest of these topics and then move into some of the multi-switch behaviors regarding things like spanning tree, port channel, trunks, VLANs, and things along those lines. Until then, I'm Terry Vinson, and I'd like to thank you for learning Data Center with me.